For today's lesson, we will be discussing about comparing the sample mean and the population mean when the sample size is large. So there are different ways on how we can compare our sample mean and our population mean. So the first way is when we know that the sample size is large. So in hypothesis testing, it is really important for us to determine if the difference between our sample mean and our population mean is statistically significant. So what we want to identify is if the difference between these two values are really statistically significant, because these two values may not be the same in value. Let's say the one is 25, the other one is 30. So we have to determine if that difference really matters or if it is really statistically significant. So that's what we want to identify in our hypothesis testing. Now, we have what we call as the Z-test of one sample mean. So this is what we use if we know that our sample size is large. So like what I mentioned in the beginning of this video, there are a lot of ways or techniques or method that we're using in comparing our sample mean and the population mean. So when should we use the Z-test of one sample mean? So there are two conditions that either of them must be satisfied or fulfilled. So first, the population standard deviation is known. So if we know the population standard deviation, if it's given in our problem, then we can apply the Z-test of one sample mean. However, if we don't know our standard deviation, but we know that the sample size is greater than or equal to 30, still we can apply the Z-test of one sample mean. If two of these conditions are not satisfied, then we have to use a different method or process in comparing the sample mean and the population mean. So for our test value, so we can compute it using this given formula. So we have here z is equal to x bar. X bar is our mean or sample mean, as what we know. And then this is our population mean. And then we have here the sample size, square root of our sample size. And of course, our population standard deviation. However, if the population standard deviation is not given, we can replace it with our sample standard deviation. So either of the two values must be present in our given problem. So we will use this formula to solve for the test value of our hypothesis testing. And last time I mentioned about the level of significance. So for each level of significance, there's a corresponding critical value to use. So in order for us to identify the critical value to use, you have to consider the level of significance and also the type of test. So if our alpha is 0.01 and it is one-tailed test, so we have to use 2.33, the positive one. If it's greater than, negative, it's less than. And if it's two-tailed under 0.01 level of significance, then we will be using 2.50. But since it's two-tailed, so we have to use both of the signs. And same as with our 0.05, so we'll be using 1.65 if it's one-tailed. So if it's two-tailed, we'll be using 1.96. Let's try it with this example. A rice miller says that the average weight of a sack of rice is 50 kilograms with a standard deviation of 4 kilograms. To test if it is true, a retailer sampled 30 sacks of this rice and got an average weight of 47.6 kilograms. Test the hypothesis at 0.05 level of significance. So you have to understand first the problem. So here, a rice miller is saying that the average weight of sack of rice is 50 kilograms. Now, this retailer wants to check or test if that is really true by getting samples of 30 sacks of rice. And then from there, the retailer was able to get an average weight of 47.6 kilogram. Now, in order to test this hypothesis, so we have to use our hypothesis testing. Before that, we have to write first our null hypothesis and our alternative hypothesis. For our null hypothesis, what we will put here is the known fact, which is the one that the rice miller says, and that is the average weight of the sack of rice is 50 kilograms. So that will be our null hypothesis. The average weight of a sack of rice is 50 kilograms. And if we will write this in symbol, mean is equal to 50. Now, this retailer, again, wants to test if it is true. So, meaning, our alternative hypothesis will be the average weight of a sack of rice is not equal to 50 kilograms, or in symbols, mean is not equal to 50. So these are our hypotheses, null hypothesis and alternative hypotheses. So we will check if we're going to reject or fail to reject our null hypothesis. So let's write first the values that we know. So from the problem, as we go back here, it was mentioned that the average weight of the sack of rice is 50 kilograms. So this one refers to the population mean. So that will be our mean, population mean. And then we have a standard deviation of 4 kilograms, which is again referring to our population. So population standard deviation is 4. Next, the retailer sampled 30 sacks of this rice. So that means that is our sample size. And then got an average weight of 47.6. So this 47.6 refers to our sample. So that will be our sample mean, which is 47.6 kilogram. And then our level of significance is 0.05. So that is our alpha. So these are the values that we know. Next thing that we have to do is to write or identify the type of test, the statistical test, and also the critical value. So let's write type of test. Since in our alternative hypothesis, we use the not equal symbol, so that means this is two-tailed test. And then for our statistical test, so let's check. What we have is the population mean. We also have our population standard deviation. And if you will go back to the conditions for our z-test, once you already know the population standard deviation, you can already use the z-test of one sample mean. So that will be our statistical test. So z-test of one sample mean. Once you already know that, so let's now write a critical value. For the critical value, so we know that the alpha is 0.05. Since alpha is 0.05 and it is a two-tailed test, that means we have to use positive, negative 1.96 as our critical value. So that will be our critical value. So once you identify those things, we now have to solve for the test value. So to solve for the test value, you just have to apply the formula. So z is equal to, we have the sample mean minus the population mean times the square root of n all over standard deviation. So that is 47.6 minus 50 times our square root of 30 all over 4. So we can now have the value. So all you have to do now is just to input this on your calculator. So the final answer will be negative 3.29. So that is now our test value. Now, to make our decision, we just have to compare this to our critical value and check if it will fall within the rejection region. So if you want, you can draw the curve. So this is 1.96. This is negative 1.96. So this will serve as our boundary for the rejection region. And then negative 3.29 is here, somewhere here. So it's on the left side of our negative 1.96. So since our test value falls within the rejection region, so our decision is to reject our null hypothesis. Because again, it falls within the rejection region. So it only means we have to reject our null hypothesis. Now, how are we going to write our conclusion? So our null hypothesis is this one. The average weight of a sack of rice is 50 kilograms. And the retailer wants to check if it is true. So using the information that he or she got from the 30 sacks of rice, the retailer was able to conclude that or decide that we need to reject our null hypothesis. This only means that thus there is enough evidence to say that the average weight of a sack of rice is not equal to 50 kilogram. So since we rejected our null hypothesis, therefore we can say that the evidence is enough for us to say that the mean or the average weight of the sack of rice is really not equal to 50 kilograms. Okay, so that is how you test our hypothesis or do hypothesis testing. So let's have another example. An education commissioner reports that the average salary of public school teachers is more than 25,000 pesos. To test this claim, a sample of 50 teachers is considered and it shows that the average salary of the sample is 23,000 pesos with a standard deviation of 4,000. Test the claim using 0.01 level of significance. Okay, so let's write first our null hypothesis and our alternative hypothesis. So since this commissioner reports or says that the average salary is really more than 25,000 pesos. So whenever you see this word more than, so automatic that will go to our alternative hypothesis. So therefore, we can write here the average salary of public school teachers is more than 25,000 pesos. And if we will write it in symbol, the mean is greater than 25,000 pesos. How about our null hypothesis? We always know in our null hypothesis, we will just put here equals or there's no difference. So the average salary of public school teachers is 25,000 pesos. So there. Or this one is the mean is equal to 25,000 pesos. So that is how we're going to write our null and alternative hypothesis. Now let's go to writing the values that we know. So this 25,000 here, this refers to our population mean. So we can write here mean is equal to 25,000. Next, a sample of 50 teachers were considered or is considered. So that is our sample size, n is equal to 50. And it shows that the average salary of the sample is 23,000 pesos. So this is our sample mean, 23,000 pesos. And a standard deviation of 4,000. So this standard deviation pertains to the sample. So that will be our sample standard deviation, which is 4,000. And then include also our level of significance, which is 0.01. So alpha is equal to 0.01. So next, let's write our type of test. So for the type of test, since we use greater than for our alternative hypothesis. So this is one-tailed test. And for our statistical test, so as you can see, we don't have the population standard deviation, but we observed that our sample size is 50, which is greater than to 30. So that means it is still applicable to use the z-test of one sample mean. And then let's identify the critical value. So this is one-tailed and our alpha is 0.01. So therefore the critical value is 2.33, positive 2.33. Now let's solve for the test value. So all we have to do is just to substitute all of the values that we know into our formula. So 23,000 minus the population mean times the square root of 50 all over our standard deviation. Since we don't have the standard deviation of the population, we have here standard deviation of the mean. So we will just put it here, 4,000. Simplify this, so we will get a critical value of negative 3.54. Now looking at our critical value and our test value, we can already write a decision, and that is to fail to reject. So we failed to reject our null hypothesis, because if we're going to draw the curve, so this is where 2.33 is, and then the rejection region is just this part. But for negative 3.54, let's say it's somewhere here. So it's not within our rejection region. Therefore, we failed to reject our null hypothesis. Now, what will be our conclusion? So if we will go back here, since we failed to reject our null hypothesis, and that means we have to accept that the average salary of public school teachers is 25,000 pesos. So it only means that there is no enough reason. There is no enough reason to say that the average salary of public school teachers is more than 25,000 pesos. So that means we don't have enough evidence to really make a claim that the average salary is more than 25,000 pesos. So that is our final answer. And for our last example, based on animal experts, cats have an average lifespan of 15 years with a standard deviation of 1.5 years. To test if this is true, a researcher gathered the lifespan of 25 cats, and it was found out that on average, they lived for 12.4 years. Test the hypotheses at 0.05 level of significance. So again, we have to write first our null hypothesis and our alternative hypothesis. So here, based on animal experts, so it is a known fact that the average lifespan of cats is 15 years. And this researcher wants to check if this is true. So we can just get the opposite of this one, and that will be our alternative hypothesis. So let's write first our null hypothesis, which is the average lifespan of cats is 15 years. So that is our null hypothesis. So if we will write it in symbol, so it's like this one. For our alternative hypothesis, since we want to test if this is really true, so we can just write the average lifespan of cats is not equal to 15 years. So the mean is not equal to 15. So that is our alternative hypothesis. Now let's write the value. So we have here again, this is the known fact that the cats have an average lifespan of 15 years. So that means that will be our mean or the population mean, which is 15. Another thing that we can see from our problem is that the standard deviation of 1.5 years is given, and this pertains to the population. So that will be our population standard deviation, 1.5. And then, the researcher gathered the lifespan of 25 cats. So that will be our sample size, which is 25. And it was found out that on average, they live for 12.4 years. So that is our sample mean. And last, our level of significance is 0.05. So that's what we will put here. Now let's write the type of test. So since in our alternative hypothesis, we use not equal symbol, so this is two-tailed. And for our statistical test, so we can see we have the population standard deviation, so that means this is Z-test of one sample mean. Now for the critical value, since our alpha is 0.05 and our type of test is two-tailed, so therefore we will be using the positive negative 1.96 as our critical value. After that, let's now solve for the test value using the formula. So you have Z is equal to the sample mean, 12.4 minus population mean, times the square root of our sample size, which is 25, divided by the sample or the standard deviation, which is 1.5. Now you just have to simplify this, and we should come up with negative 8.67. And then since we already have our test value, we already have our critical value, so we can now compare. And since the test value is negative 8.67, that means it is really it will fall on the left side of our negative 1.96 critical value. So that means we have to reject our null hypothesis. So what now will be our conclusion if we reject our null hypothesis? So when we say reject, so we will not consider our null hypothesis. Thus, we can say that there is enough reason for us to say that our alternative hypothesis is true. So thus, there is enough evidence to say that the lifespan of cats is not equal to 15 years. Since we rejected our null hypothesis, that means our evidence is enough to conclude that the lifespan of cats is not really equal to 15 years. So that's it for today. I hope you learned something how to compare our sample mean with the population mean when the sample size is large. What are the things that we have to remember about hypothesis testing? And see you next time.